Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the overview of today's session. Today we will be discussing about merge sort and its introduction part of it. Then we will be seeing about the merge sort algorithm, and we will be seeing the example for merge sort. And at last, we will be seeing the implementation part of merge sort also. Okay, let us go for the introduction part of merge sort. It is simple as we have seen with the quick sort. Merge sort uses divide and conquer paradigm or algorithm for sorting. As we have seen, divide and conquer is, divide is nothing but if you have given a large problem, that will be divided into sub-problems. This is going to be divided into sub-problems. And those sub-problems are going to be solved. In conquer, these sub-problems are solved individually. And then, these are going to be done individually. And then, we are going to combine them. Combining is nothing but the merging, right? This is the one which you are going to do it in merge sort. And as we have seen, it divides the problem into sub-problems and solves them individually. It then combines the results of sub-problems to get the solution of the original problem. The same process where we have seen in quick sort also. Okay, let us see the next. This is the merge sort algorithm. Let us see. Merge sort is a popular sorting algorithm for its efficiency and stability also. When compared with quick sort, the merge sort is more efficient and it will be having the stability also. And it follows the divide and conquer approach to sort the elements in the sorted order. Again, the same process here. Divide the list, first division, conquering and merging. These are the three steps again we are going to follow. Divide the list or array recursively into two halves until it can be no more be divided. Previously, we have done something different in the quick sort, right? Here, the list whatever you are going to get, that will be divided recursively until we are unable to divide it. That means we are going to get the individual elements. Until that, we need to perform the division. Then, each subarray is sorted individually using the merge sort algorithm. Using merge sort algorithm, we are going to solve the subarrays. Whatever the individual things we are going to get or subarrays we are going to get, we are going to sort them individually. Then, the sorted subarrays are merged back together into sorted array. After having that sorted subarrays, we are going to merge them. That means we are going to combine them and make together into the sorted array. The process continues until all the elements from both the subarrays have been merged. We are going to divide it and then sort them separately and based on the subarrays, and then we are going to combine them. This is the one where we are going to do. Let us see the example so that you could understand very easily how the merge sort is going to work. Consider these are the elements we have. Totally we have 6 elements in the array. Now first we need to divide the list into two halves. For that we have mid equal to low plus high by 2. Based on this we are going to divide the list. Right, you all know the indexes of this 0, 1, 2, 3, 4, 5. The low represents the index 0 and high represents the index 5, right? Based on this, find the mid value. 0 plus 5 by 2, you are going to get 2 point something, but don't take the decimal part, take only the integer part. That means we are going to consider to 2. 2 is the mid value, right? From here we are going to divide. This is the mid part where we are going to have. From 2 that is one sublist, and from 3, 4, 5 that is another sublist. Now again you have the indexes of this one is 0, 1 and 2, and this is 3, 4 and 5. Now apply again the same mid logic, mid condition here also. This is low value again, this is high value, that is 0 plus 2 by 2. Where is the mid position we are going to get? At 1. That means from 1, that means up to here, 1 and this one, this will be divided into 2 parts. 6, 2 will be as one part, that is 0, 1 index will be as one part and index 2 will be as another part. Every time you need to represent that indexes, based on that we are going to divide the list. Okay. And if you are going to check 0 plus 0 and 1, again apply the same 0 plus 1 by 2, that is you are going to get 0.5, but don't take the decimal value, we need to take only the integer part, that is 0. That means that these two elements also are going to be splitted based on this 0. 0 and 1, this is index 0, this is 1 and this is 2, this is already splitted, and we need to see on the other part also. These elements are divided individually until this from here we are unable to divide it. Why? Because we have the individual elements. Okay. Then come to the right side of it. Now again from here we need to find the mid and we need to divide the list. That is nothing but here what is the low value is 3 and high value is 5 by 2. That is 8 by 2. So that we are going to get 4. That means from 4 we need to divide the list into 2 halves. That is 7, 5 as one part and 4 as another part. Right. Now again repeat the same process for this. 3 plus 4 by 2, that is 7 by 2. 7 by 2 is nothing but 3 point something. That means it will be divide the list at 3, 4 and 5. Right. Like this way the splitting is, we have done the division part. We have divided the list into individual elements was done. Now after division we need to merge them. Right. While merging, what we need to have is, while merging the individual array list into the subarray, at the time itself we need to place them in the sorted order. Right. How we have split it? In the same way we need to merge them. The subarrays we need to merge them, and based on that we need to place them in the sorted order. Now you see, if you could see here, we have splitted 6, 2. Right. We need to take these 2 first. 6, 2 has been splitted. Right. These 2 are going to be merged. While merging that subarrays, we need to place them in the sorted order. Like this way, 2 and 6 you are going to get. I think so. I hope you are going to get this one. Right. While merging, we are going to place them in the sorted order. Right. After that, we have the element 11. These 3 elements have to be merged now. This is one subarray and this is another subarray. We need to merge them, and while merging them, we need to place them in the sorted order. That is 2, 6, 11 are going to be merged. That means you are going to get that subarray as the sorted list. Then come to the right part. We have splitted 7, 5 first. If you could remember this, yes, 7, 5 has been splitted. Those 2 are going to be merged and place them in the sorted order, 5 and 7, and at last you are going to have the 4 as it is. Next, when you are going to merge these 3 elements, those should be placed in the sorted order, that is 4, 5 and 7. And at last, you need to merge these 3 elements with these 3 elements, that is left and right, we can say. Right. So when you are placing them, those all elements should be in the sorted order. That is, first I need to place 2, then 4 from here, then 5 from here, 6 from here, then 7 and 11. Like this way we are going to place. According to this, we need to write the logic also. Okay. We need to check the subarray list and check with whether the elements are on the left sublist or right sublist or lesser, comparing, and based on that we need to place that into the another array. Okay, another extra array we are going to take and we are going to place them, and at last we are going to place it in the actual array and that will be displayed. Okay, this is how the merge sort is going to work. Now we will see the implementation of this merge sort. Let us see what we are doing here. At the first step, what we did, this is the one where we have completed the given list is divided into individual elements, right? For that, what is the logic we need to write? Here we are going to take two functions, one is for merge sort and another one is for merge. The merge sort, what it is going to do? You are going to check with low and high value first. Now first we are going to divide the list into two halves, right, and then individually, right. For that, what we are taking, what is the first case we have taken? Mid equal to low plus high by 2. This is the step where we have done, right. This is the step where we have done. Now after doing that, after dividing the first list into two halves, again we are going to call that recursively for the left sublist and right sublist until they become the individuals, right. Now merge sort of A comma, if you have a list like this, the mid part you have find it out, this is low value and this is high value and this is your mid. Now the left sublist we need to take recursively and right sublist also recursively. Now what I can write, the name of this is array A, right. A comma, low comma, this is nothing but mid minus 1. Or we can take up to mid, right? Up to mid we can take mid. A comma, low comma, mid, that is 1/2. Up to half we are going to take that middle value also. And the other part is, this is this up to here over. Now the next one, which part is, we have mid plus 1. Mid plus 1 to high, the next list we are going to take. That's why merge sort of A comma mid plus 1 comma high we need to take it as the right subarray. And after taking all these subarrays individually, and then we are going to merge them. While merging, how we are going to merge? Merge of, this is the function, merge of A comma low comma high comma mid. A value, this low value, high value and mid value, all has to be combined. For this we need to write again separate logic. This is for up to the individual splitting we are going to do. After individual splitting, we need to merge them. For that, we are going to write this subfunction. Now let us see, this is the subfunction where we have. Here we are going to take the same low, high and mid as the function names. We are taking one more extra array, that is C of 50, and I value, low value, I value, j value and k value are going to be assigned. I is assigned with low and j is assigned with mid plus 1 and k is also going to be assigned with low. And based on these loop iterations, we are going to check the two subarrays, and in the first subarray the element is lesser. First we are going to place it in the C of C array. Otherwise, in the right subarray, if the element is lesser, then we are going to place that element in the C array. Okay. According to this logic is going to work. If one of the element is left over in the left subarray, but we have completed in the right subarray, in that particular case, after closing this while loop, again we need to check these two conditions. If it is left with any of the element left in the left sublist, we need to check with the condition, this condition, and we need to place the element. If any of the element that is left over in the right subarray, then we need to check this one, and according to that we need to place it into the extra array name which we have taken. And at last we are going to move the array that is present in a C of I is going to be placed into A of I, so that we can print the array elements. Okay. This logic, if you want to understand, let us go with the example so that you could understand very easily. This is the sorted array, where this is the name of this one, you consider it as C. Previously we have taken, at the time of reading we have taken it as A, but now we are going to consider this as a C. And the name of the variable which I am going to take it as K, where it is pointing to the low value. And we have the left sublist and right sublist. I am not taking from the individual, I have taken from the 3 elements. If you could see here, these are the 3 elements and these are the 3 elements that was present. According to this, how we are going to perform the merging? Let us see. Now first condition what we have, if I less than or equal to mid and j less than or equal to high, if this condition satisfies, then we are going to proceed with these 2 cases, right? Here I value is less than or equal to mid and j is also less than or equal to high, we are proceeding with this. Now I is pointing to the low value and j is pointing to the mid plus 1 position. Okay, this is the initialization where we did it. I equal to low and j equal to mid plus 1, and k is also pointing to the low value, and this is nothing but the low. Low is nothing, the index is 0, it is pointing to. Now coming to the first step, what we need to check. You need to check with this condition. If a of I value is less than a of j value, then what you need to do? A of I should be placed into C of k, and then I will be incremented, at the same time k is also going to be incremented. If a of I is not less than a of j, then go for a of j value, that is right sublist value is going to be placed into C of k, and j will be incremented and k will be incremented. If you remember these 2 cases, so that we can proceed with this logic. Okay. Now what is the first case? A of I is less than a of j. Now check with a of I value is 2 is less than a of j value is 4. Yes, the condition is true. So that what we need to do, we need to place this a of I value into C of k. That means we are going to place 2 here. And at the same time, k should be incremented and I also should be incremented. I is here and k is here. Okay. Next, again repeat the process. I less than or equal to mid and j is less than or equal to high. Now again check the condition. A of I value is 6 is less than a of j value. J, we didn't have any change, right? J value is 4 only. Is 6 less than 4? No. It will go for the second case, right? It will be going for the second case, so that a of j value will be placed into C of k. A of j value is how much? 4 is going to be placed into C of k, and j will be incremented, at the same time k is also going to be incremented. Okay, the same steps I am going to show here also, right? Incremented, 2 and 4 is placed, so k is at this position. Now again check for a of I and a of j values. Now what is your a of I value is 6 is less than a of j value is 5. Is 6 less than 5? No. Which is the smallest element that is present in the list? 5 is the smallest element. That has to be placed into the array. That means this 5 is going to be placed into the array C of k, and j will be incremented, at the same time k is also going to be incremented. This is going to be happen, right? After placing that, now you are in this particular step. Okay. Again check with a of I value. A of I value is 6 is less than 7. Yes, 6 is less than 7. Now which element we need to place? We need to place the element which is on the left hand side. That has to be placed into the array, right? Now placing 6 into here, right? At the same time k will be incremented and I also going to be incremented. Done. Now again check for the next case. A of I value is 11. 11 is less than 7. No, condition fails. So which element is smaller here? 7 is the smallest element. That has to be placed into the list. 7 is placed into the list. Now increment the j value and increment the k value. Both has been incremented. Now we have the first iteration condition should be satisfied, that is I less than or equal to mid and j less than or equal to high. If this condition satisfied, then only we need to repeat this process. But what happens here? I value is, this is 0, 1, 2, 2 less than or equal to mid value is also 2 condition trues, and j value is this is 3, 4, 5, but j becomes 6 less than or equal to high is 5 only. Here the condition fails. That loop will be terminated. Now we have written another sub conditions also, one for the left sublist and another for the right sublist. But which of the element is left over? 11 is left over. That means we need to check only this condition. While I less than or equal to mid, in this case, if A of I is greater than A of j, no need to check the condition also. We are left with only one element here, right? Let us see the algorithm. Yes, no need to check any condition. We are left with only one element here. So that no need to check this. Directly we are going to place this 11 into this C of k. Now that is C of k, this into this A of I value is placed into C of k, so that I will be incremented and k is also going to be incremented. Now if I am going to check for these cases also, I less than or equal to mid and j less than or equal to high, all the cases are going to be failed. So that if you can check the array, all the elements are placed in the sorted order. This is how this merge sort is going to work. Yes. And if you can see the time complexity of this, the time complexity for a merge sort, best case, average and worst case all will be the same, big O of n log n, right? Now we will be seeing about the execution part of this merge sort once. Yes, whatever we have discussed, the same code I have placed here. Just I am declaring a variable A array, that is with 100 size, declaring globally. Why? Because I am using the same variable in my sub function also. Because of that, I am declaring my variable globally. Okay. Next, here I told you we are using two functions. One is for merging, another one is for merge sort. The merge sort is going to split the list into two halves, and merge function is going to merge the individual subarrays into the single one. That's why we are going to use two functions. And this main function, this as usual we are going to use in all the sorting techniques, where we are going to read the size of array elements, and this is for reading the array elements, and before sorting what you have, and after sorting what is the sorting result you are going to get. And with that, this is the main thing where you are going to call your merge sort function, not merge function, merge sort function we are going to call. Okay. Now based on this merge sort function, we are going to divide the list into two halves, and we are going to call them recursively to make them individual. And after doing these two steps for division, and at last we are going to merge them by calling A, low, high and mid values. All the values we are going to take, and we are going to merge the individual list into a single list, right? This is for merging. And if you could see the same logic which we have seen up to now by solving with an example, right? Here we need to initialize I, j values and k value, and if I less than or equal to mid and j less than or equal to high, we are going to check the left sublist as well as the right sublist elements, and according to that we are going to place them into the array which we have taken. And if any of the element is left over in the left sublist or right sublist, then if the this loop is terminated also, then we can go for these two cases, right? After doing this, we are going to get the resultant list of elements which is sorted into the C array. That one we are going to again copy that into the array, right? So that you are going to get the resultant of this. Now you can able to execute this one, and we will see how this is going to work. Let's take some 5 elements. I am giving 6, 4, 1, 3, 2, sorry. Take 5 elements. 1, 4, 2. Yes, now you can see 3, 7, 1, 4, 2 is the elements which I have given in the unsorted order, and after sorting we are going to get the result as 1, 2, 3, 4, 5, right. This is how you can implement this merge sort also. Yes, I hope you understand this concept. Let us see the summary of this merge sort. In this we have seen about the introduction of merge sort. Then we come across the merge sort algorithm. In that we come across two functions, merge sort and merge function. Two functions we are going to use. Then we have seen the example of merge sort and how the merging is going to be done also seen. And at last we have seen the implementation of merge sort also. I hope you understand this. You can try to implement this code and at the same time take some examples and try to apply this merge sort and how we are going to divide them and how we are going to merge them. Okay. Thank you.